Everything you think you know about empty space is wrong. Between the galaxies, in the vast, lightless distances that stretch for hundreds of millions of light years in every direction, something is there. Scientists used to call it the void. They thought it was nothing, a blank, the universe's version of a blank page. But the more we look, the more we find that the spaces between galaxies are among the most complex, most violent, and most structurally important regions in the entire cosmos, and what's hiding out there in the dark could change everything we think we understand about where we came from. Let's start with scale. The gap between the Milky Way and the next large galaxy, Andromeda, is roughly 2.5 million light-years. That's a distance so large that a beam of light, traveling at 186,000 miles per second, would take 2.5 million years to cross it, and Andromeda is our nearest major neighbor. Now multiply that by the billions of galaxies we can observe, clustered into groups and clusters and superclusters, all separated by those yawning, dark expanses. That's the stage we're dealing with, and it is not empty. The intergalactic medium, scientists call it the IGM, is the name for everything that lives in that space: gas, plasma, radiation, magnetic fields, and matter we can barely detect. It is the ocean between the islands. It is thin beyond anything we have words for. The density of the IGM is less than 1 atom per cubic meter in many regions, which makes the best vacuum we can create on Earth look crowded by comparison. But thin is not the same as nothing, and across the billions of light years those numbers add up to something staggering. Here's a number that will reframe everything. 76% of all the normal matter in the universe, the protons, neutrons, atoms that make up everything you can see or touch, does not live in galaxies. It lives between them. Stars, planets, entire solar systems like ours make up a relatively small fraction of where matter actually is. The bulk of it is out there, drifting in the dark, in the intergalactic medium. That means if you want to understand the universe, looking at galaxies alone is like studying the ocean by only counting the fish. Now zoom out further. The universe is not arranged randomly. It has architecture. There is a structure to it so enormous, so geometrically precise that when you see it rendered at full scale, it looks less like physics and more like something deliberate. Astronomers call it the cosmic web, a three-dimensional network of dark matter filaments, hundreds of millions of light-years long, connecting galaxy clusters the way threads connect the nodes of a vast invisible net. Where those threads cross and knot, you get the densest galaxy clusters in existence. And between them, the voids. Dark matter accounts for roughly 85% of all the matter in the universe. You cannot see it. You cannot detect it directly, but gravity betrays its presence, and those dark matter filaments are the skeleton of the cosmic web, the invisible architecture that pulls gas and galaxies into lines across the sky. In February 2025, an international team captured the highest definition image ever taken of one of these filaments, a thread of gas and matter 3 million light-years long, connecting two galaxies from a time when the universe was just 2 billion years old. 3 million light-years. A single thread in the web, and we are only now learning to see it. But here's what stops you cold. The James Webb Space Telescope has now looked back to within 830 million years of the Big Bang, less than 6% of the universe's current age, and it has already found the cosmic web forming. A structure of 10 galaxies, arranged along a filament anchored by a quasar with a black hole weighing more than 1 billion times the mass of our Sun. Those galaxies already lined up, already falling into place, already following the invisible architecture of dark matter. The cosmic web did not build itself slowly. It snapped into form with a speed that surprises even the scientists who predicted it. Now hold that image in your mind, the web, the filaments, the structure, and then consider what sits inside the voids between those filaments. The Boötis void. Say that name slowly. It deserves the pause. Discovered in 1981 by astronomer Robert Kirshner during a survey of galactic structure, the Boötis void is a roughly spherical region of space, 330 million light-years across. Its center sits roughly 700 million light-years from Earth, in the direction of the constellation Boötis. For context, the entire distance between us and the Andromeda Galaxy, that gulf we called staggering earlier, would fit inside the Boötis void more than 130 times. You could travel from one side to the other at the speed of light and still be crossing it 330 million years later. Inside this region, astronomers expected to find thousands of galaxies. Standard cosmological models, which have been right about almost everything else, predicted a roughly normal distribution of galactic matter. What they found instead was 60 galaxies. 60. In a region that should contain closer to 2,000. Cosmologists call it the Great Nothing. If the Milky Way were located at the center of the Boötis void, we would not have detected any other galaxy until the 1960s. Our entire history of astronomy, our entire understanding of the cosmos, would have developed with nothing to point a telescope at. How does something like this form? The leading theory is that the Boötes void is the product of smaller voids merging over billions of years. In the early universe, quantum-level fluctuations in matter density, barely perceptible differences, subatomic ripples, caused some regions to pull matter away from neighboring regions. Slightly denser areas got denser. Slightly emptier areas got emptier. Over cosmic time, those small differences amplified into the large-scale structure we see today. The rich galaxy clusters, the long dark matter filaments, and the vast emptiness of the voids. The Boötes void does not violate our models of how the universe works, but it sits at the very edge of what those models comfortably allow. And this is where it gets strange. Because inside the void, inside all the voids, something does exist. Something is filling the space. Dark energy. It makes up 68% of everything in the universe. It is the single most abundant component of the cosmos. And unlike dark matter, which clusters, which pulls, which follows the filaments, dark energy does not cluster. It spreads evenly. It fills the voids preferentially. Scientists have found that dark energy dominates the mass energy budget inside cosmic voids earlier than anywhere else in the universe. The voids are where dark energy is most in control. They are the engine of cosmic acceleration, the force driving the universe apart at an ever-increasing rate. And that rate is not slowing down. Some physicists now argue the voids themselves may be responsible for what we call dark energy's effect. That the cumulative push of all those vast expanding near-empty regions, working together, could be generating the accelerating expansion we attribute to a cosmological constant. The void is not just an absence. The void is an active participant in the fate of the universe. Now let's talk about what else lives out there, because the intergalactic space is not as lifeless as it appears. You have heard of rogue planets. Planets that were flung out of their solar systems early in planetary formation, cast out by gravitational interactions with larger bodies, sent tumbling into the dark with no star to orbit. Astronomers now believe there are nearly 2 rogue planets for every star in the Milky Way alone, billions of them, wandering in the dark between star systems. Some of them have almost certainly been flung further, out of the galaxy entirely, into the truly intergalactic void, where they drift in permanent blackness, warmed by nothing, lit by nothing, orbiting nothing. But there are also stars out there, real burning stars. In the Virgo cluster, the massive galaxy cluster closest to our local group, astronomers estimate roughly 1 trillion stars exist not inside any galaxy, but between them. These are called intergalactic stars, or intra-cluster stars. They formed inside galaxies. Then, galactic collisions, gravitational tides, and close encounters stripped them loose and flung them into the spaces between. Some estimates suggest that as many as half of all stars in the universe may exist outside of galaxies. Half. Every second star you can imagine, untethered, drifting, part of no galaxy at all. These orphan stars emit what astronomers call intra-cluster light, a faint, ghostly glow that spreads through galaxy clusters. In August 2025, astronomers detected a 1,000,000 light-year-long bridge of this intra-cluster light connecting 2 massive galaxies inside the Abell 3667 cluster, 700 million light-years away. A thread of stars stretched between 2 colliding systems, not a galaxy, not a filament. A ghost bridge, a bridge of suns, and there is gas. Enormous amounts of gas. Recall that 76% of normal matter sitting in the intergalactic medium. A large fraction of it exists at temperatures between 100,000 and 10 million degrees Fahrenheit. This is what scientists call the warm-hot intergalactic medium, the WIM. It is a plasma. Protons and electrons stripped apart by the heat of gravitational collapse, compressed along the filaments of the cosmic web, glowing faintly in X-ray light. You cannot see it with the naked eye. You can barely detect it with the most powerful telescopes on Earth. And for a long time it was missing. The missing baryon problem is one of the most unsettling puzzles in astrophysics. When scientists calculated how much normal matter, baryonic matter, should exist in the universe based on the Big Bang and the cosmic microwave background, they came up with a number. Then they added up all the matter they could actually find, in stars, in galaxies, in galactic gas clouds, and the 2 numbers did not match. Between 30 and 40% of all the normal matter the universe should contain was simply not showing up, unaccounted for, missing. The WIM appears to be where most of it is hiding. Observations of highly ionized oxygen atoms in the intergalactic medium, detectable only by their faint signatures in X-ray spectra, confirm that the filaments of the cosmic web are threaded with hot gas that carries the missing baryons. The gas is there. It is just incredibly difficult to see, scattered across filaments spanning hundreds of millions of light-years, with a density of less than 100 hydrogen ions per cubic meter. You could park a spacecraft inside a column of WIM a football field long, and it might intercept a single atom. But those atoms add up, and what they tell us is that the universe's matter never disappeared. It just went somewhere we weren't looking. Here is the thing about the intergalactic void that should unsettle you most. The Boötes void, the cosmic web, the WIM, the orphan stars, the rogue planets, the ghost bridges. None of this was known with any certainty 30 years ago. The cosmic web was predicted mathematically, but we could not photograph it. The WIM was theorized but unconfirmed. The intracluster stars were detected only as faint statistical anomalies in galaxy cluster measurements, and the Boötes void, when discovered, was so surprising that astronomers spent years suspecting it might be a measurement error. Now, the James Webb Space Telescope is peeling back layers of the universe that no instrument has ever reached. It has photographed the earliest strands of the cosmic web. It is confirmed that the architecture of large-scale structure was already in place less than 1 billion years after the Big Bang. In January 2026, researchers published the most detailed dark matter map ever constructed, using JWST data to track nearly 800,000 galaxies and reveal the cosmic web structure with twice the resolution of anything Hubble could achieve. The web is real, the filaments are real, the voids are real, and we are only beginning to understand what lives inside them. Think about what the cosmos actually looks like at the largest scales, not the familiar images of individual galaxies, those spiral arms, those glowing cores. At the scale of hundreds of millions of light years, a galaxy is a point of light, a city of hundreds of billions of stars reduced to a single pixel. And those pixels arrange themselves into lines, into sheets, into vast planar structures and long curving filaments, all connected, all continuous, all part of one single immense object, the cosmic web. The largest structure in the known universe, and threaded through all of it, the dark, the void, the IGM, the WIM, the ghost stars and the rogue worlds and the dark energy that is, right now, pushing everything apart. The universe is not a collection of objects sitting in empty space. The space itself is the story. Every cubic meter of intergalactic void is a data point. Every atom of superheated WIM plasma is a record of how matter traveled across billions of years. Every orphan star, drifting between galaxies, carries the gravitational scar of a collision that happened billions of years before our sun existed. Nothing out there is empty, not really. What we called empty was only ever a measure of our inability to see. And the question now is not whether the void is empty. We know it isn't. The question is what else we haven't found yet. What other structures, what other forms of matter or energy or physics are sitting out there in those 330 million light-years of the Boötes void, in those intergalactic filaments, in the hot plasma threading between galaxy clusters, waiting for a telescope powerful enough to see them? So here's what I want you to think about. If half of all the stars in the universe exist outside of any galaxy, drifting in the intergalactic void, what does that mean for life? Could there be planets orbiting those orphan stars in the permanent darkness between galaxies, with no night sky full of stars, no galaxy overhead, just blackness in every direction? What would a civilization born in the true intergalactic void even know about the universe? Tell me in the comments, does that idea fascinate you or terrify you? Because I can't decide. If this stretched your sense of scale, hit the like button and share this with someone who thinks space is mostly empty. And make sure you're subscribed, because next week we're going somewhere even stranger, the moment before the Big Bang, and the question of whether anything existed at all.